worked on the face detection example using HAAR cascade, and I said in that we will discuss what is exactly HAAR cascade in our uh, today's session. Okay, so yeah, let's now talk about it in depth. What exactly is HAAR cascades and how does it actually it works and how it is useful in our detection of the object like faces, smile, eyes. So let's try to understand it how exactly the HAAR cascade techniques work. Let's start by using HAAR cascade. HAAR cascade classifier or HAAR cascade simple. Let's start with that. In order to discuss HAAR cascade, let's start by first. This is one of the object detection algorithm. It is used as an object detection algorithm
Excuse
used
me, sir.
to
Uh,
identify. Yeah, what happened?
Sir, I have a question.
Yeah, please ask your question. Hello.
Hello, sir, and I'm audible to you.
Yes.
I'm saying that I was working on ROI, that is reason of interest there. So when I was running my code on Jupyter, it was giving me an error -27 null pointer. And after a lot of effort in my daytime, I didn't able to rectify this error.
Null
What
means
could be the...
your path is wrong.
No, no. In fact, before that, the file was reading completely using cv2.im show.
Maybe you are
But
done taking a null indicates that your path is your data that you have taken is null. That is what it
exactly,
means.
exactly. But the
Hmm.
point is that this IM pug image, which I was showing using cv2.im show, sir, it was displaying properly. But after set mouse callback when I was running, and just to get the coordinates, no, which you have told us, then there it is showing the error -27 null pointer, sir, and it is giving
Minus
the error.
27. Which line?
Yes.
Sure. Paste the error in the chat. Make the set mouse callback and the cv2.im show. When I was working on it, I kept their name same, the frame
Uh,
name. In your case, it is given differently. Don't do that. That's why you're getting the error.
Original pug and original position. That is the reason, sir.
Yes, yes. It is used as an object detection algorithm. I'm talking about the HAAR cascade classifier. This is one of those algorithms which is used for object detection, and it is used to identify faces in an image or real-time streaming video. In both of these examples, it can identify the object. That's the main purpose. Talking more about the HAAR cascade, uses edge or line detection feature. HAAR cascade uses edge or line detection feature techniques to particularly identify the features for the objects. HAAR cascade algorithm is already trained with multiple positive images consisting of things like your faces. If you are using HAAR cascade to detect the face, so it will have that faces in it, or as I said, it could be eyes or smile, etc. And parallelly, it also have a lot of negative images, and those negative images will be not a face. So it contains a face It contains not a face. Faces are your positive images, and not a face is your negative images. This trained model is stored as an XML file. The already trained model is stored as an XML file for face, full body, eye detection, eye smile. We have a list of all these available to detect the faces. Okay. Now, as I said that it will basically first, the HAAR cascade uses different techniques to extract the features from the images. And in order to do that, it will take a portion of rectangle. Rectangular shapes are there which it can use, and it could be of different combinations. Okay. Let me share you the link from where you can get all the HAAR cascade files which could be used for multiple detection. This is the link, GitHub link it is, where you can see to detect things like your frontal face, full body, if you will follow the link, then eye with the glasses, eyes, etc., etc. The latest inclusion will be, I think, license plates as well. So these are the official HAAR Cascade location files which are available from the OpenCV. Now let's talk about the different shapes of features extraction, which look like this. We have a combination of black, different rectangle shapes are there, which is basically shown as a combination of reds and whites and blacks. Now this black and white has a meaning. What it means here is that that this will be used, like if you will talk about the first two combination A and B, they are used for edge features. If you will talk about C and E, they are used for line feature. They are called as line feature. C and E, they are called as line feature. And my D part is known as four rectangle, four rectangle feature. So A and B are known as edge feature selection, line features, and four rectangle feature. So features are from the images are detected in this way. Features from images are detected by following techniques. Let's imagine and let's take any shape here, any image. Let's say I'll take, okay, this is my images that you observe. So once we have got here the faces, let's try to understand that how the features will play its role. So this particular shape that we have taken, it will basically be placed over the face and it will move across the whole surface. Okay, and from the original image, it will try to create feature extraction, and in order to do that, it can take these different combinations for edge features, for line feature, and for rectangle features. Let's imagine that we have taken a four rectangle feature which will be placed over here. Okay, this is how the shape looks like, isn't it? Now on one of the part it is black, the other part is white. What is the meaning of that? Let's say the portion that is black here, let's take that and it will hover around the overall image. This is all black here, and on the other side we have got all the whites. Okay, this type of shape will be created, and remember that this will be moved across through the whole surface. Okay, it will move around the whole image. What will be the resultant of this? If you will look at here, every image will be ranging itself from 0 to 1 value, or you can say that it will be between 0 to 255. That's how your images will look like, isn't it? So imagine that if this is the image, over that particular portion, what exactly will happen? The whites are basically considered to be zeros, and the blacks are considered to be 1. These are all zeros, and the blacks are 1. Okay, now this will basically be multiplied, or whatever the portion is there, it will be selected like that, and it will sum all the data. It will basically sum all the value in that particular portion. Let's look at here. Let's talk about something like this. So what did I said that here, this is all your zeros portion. These are all zero. Similarly, we'll have all the ones. It will multiply with the pixel values over that particular region. Let's say that this is how your images are. This is the selected image region, and these are all filled with value. Those value will be something like zero point 0.4, zero point 0.5, zero point 0.3, zero point 0.2, like that. Why? Because this 0 to 255 can be also converted into a range of 0 to 1 by dividing all the pixel position by 255. This process is called as pixel normalization or image normalization. Now, whatever the color portions which falls under 0, that will be there, and it will be subtracted from the images which are under the black. So we'll be having the images under the white minus, so add all the value minus, add all the value which are under the black. So as I said, it will be sum of pixels in darker area in white region minus sum of pixels under your dark region, and we will get some final number or final value. Whatever the final value that we have got, so remember that this is your original image pixel, and this is your kind of your shape of the HAAR cascade detector. So it will add all these numbers first, sum of all the whites minus some of the all the blacks, and we will get here some number. Now that particular number will basically be checked with the help of the cascade classifier. Hope you are getting it. This will be checked with the cascade classifier. So under white region or light region, or under the dark region or the black region, we will get it. This will give you some number. Let's say the number comes out to be 1.3. Okay, I'm just assuming that this will be number 3, because see, this value will be something like this. Okay, 0.1, 0.2, 0.05, 0.2, 0.2, 0.3, 0.2, 0.1, 0.5, 0.6, something like this. These are all your color value. Remember that your color generally you have seen it in range of 0 to 255, but this can be also ranged to 0 to 1 by dividing all the color pixels by 255. Now once we have got it, this particular value, we have to use something known as cascade classifier. So simple calculation is going on here. This resultant value is simple calculation of, I can write here in fact, simple calculation of HAAR cascade from rectangular image section has been shown. Now we need to see that whatever the feature we have got, if this is greater than threshold value or not. If this is greater than threshold, we will say that feature is classified as face, or feature is classified as object, whatever the object you are wanted to detect. In this case, it will be face. So the whole idea is to basically find this particular region, this particular portion we need to detect. As you can observe that we need to find the rectangle around the faces. So my HAAR cascade is already trained with the multiple lot of positive and negative images. So what it will do is it will try to detect the region, sorry, it will try to detect this particular region, and when I say that it will detect it, it will return me four things. Using the HAAR cascade classifier, it will return me four things. What are those four things it will return? The start value of x and y, and it will return me the height and width of the face, so that we can apply here x plus w and y plus h to get the final coordinate as well, and we can draw the rectangular boundary so that we can say that the face object is detected. Now in order to detect the face, we will also use a method, a classification method, which is called as cascade classifier. And this cascade classifier algorithm will take your HAAR cascade file, which is obviously the XML file that contains all your trained model details. This is your trained model. So the cascade classifier, it will basically be able to detect and get this particular value, and it will check whether this is greater than the threshold value or not. And once it is done, once the model is created, we will also use something known as detect multiscale function, which is basically used edge features of face. That means it will return me four things: x, y, w, h. That's it. This is the theory. Now, in order to detect it correctly, which will return me four things, it uses two things. One, the threshold value, which will be provided by the user, and also it detects via the method of nearest neighbors, that how many other nearest pixels are supporting that it is a face or not. So let's say this is the new feature that has been selected. This is my new feature. Now to my new feature, I will basically be applied here. I will be applying in this my other pixel values, which will be somehow here. Okay, remember that these are other already selected face features, and there are some other features which are indicated as not a face. Is going on like this: 1 and 2. Let's try to calculate the now. So we need to find that how many nearest neighbor supports are there, how many number of nearest neighbors are there. These are my neighboring features, and from the neighboring features we will check if it is giving you proper voltage for this particular new feature value or not. Whichever gives you the majority, according to that the classification will take place. So as I said that this is 1, which indicates that it is first, and this is 0, which indicates that it is not a face. So if I have said that there are number of nearest neighbor is 5, so number of nearest 5 will be supporting this, and whichever is majority according to that, this selected region will be either part of the face or will be not part of the face. 1.3 is the feature which is extracted by performing this particular activity that we have discussed.
Suppose this, but I just I'm not getting actually everything that you said. I'm finding difficult to understand and relate. Suppose this 0101, the box, rectangular box that we are showing, we need to fill the whole image with this 0101 kind of thing. Then
No,
what
no,
is the
no, no, no.
score of 0?
No, no, no.
Then
1 second. 0 indicates here white color and or black, 1 is indicating black color. That's the only significance. It is not going to multiply with 0 or it is not going to multiply with 1. It is just indicating what is the number of portion of black region and what is the portion of white region. And we will select this particular whole value, and we will select this particular whole value, their summation.
no, your mouse, if you are moving somewhere, it's not visible.
No, I'm
Yeah,
not
now it
moving
is visible.
anywhere. I'm not moving.
So summation of zero, you said, summation of this particular value.
Summation of image region which is under this portion
Uh-huh.
minus this portion gives you
Oh,
this.
okay.
Threshold value we will provide it. We will provide a threshold value just like the way it happens with other classifications similar to that. Like we will provide it 1.3, 1.4 or anything like that, and accordingly it will do the calculations. Algorithm can be applied not only to the faces but to every different objects which are available. I shared you one link. Did you open that? Open it. You will find the different type of detection that HAAR cascade can do. And also I have been saying that it can be used to detect face. It can be used to detect eye. It can be used to detect full body. It can be used to detect only the lower body. These are all the things it can do. Done with your questions?
Hello. Yeah. In the XML files which you have given link and you have already given last week. So in that XML file, is it that the algorithm is implemented and written?
All the XML file is a trained model.
Okay.
That
So
means
the train
it
model.
has. Let me complete
Yeah. Yeah.
first.
Sure. Sure. Sure.
It means that it is having all the positive images and the negative images.
So what do you mean by positive, negative, white and black?
No, positive means the object that we wanted to detect, and negative means whatever the object we don't want to detect. I mean, let's say face is my HAAR cascade. I wanted to detect face, so it will be positive, and not a face will be negative.
So the HAAR cascade for face detection is a trained model only to detect face.
Yes.
So same way there are so many other XML which refers to different thing like left eye, right eye, full body, whatever you are saying.
Correct.
And when you say that the algorithm, it uses an object detection algorithm. So the algo is already written and it is embedded in that XML file. Means we have to directly use it with some. It is like an API where we use some methods and then try to apply it to our required image. Is that right?
Yeah, correct.
Okay, because the last week whatever you have given, there is something called face cascade. You created an object using the cascade classifier. The cascade classifier class of OpenCV you used to create an object called face cascade, and within that case face cascade, now it is written in the face cascade XML that we have to give the three parameters, something like gray 1.35. So all this is like whatever you are explaining to. So each as we move from one phase cascade to like other, like left eye, right eye, full body, the methods also change, or the logic is same but modification is slightly tweaked.
You need to make changes in your threshold.
Okay, but the method like detectMultiScale, that remains same,
Yeah,
or
that
do we
will
need to
remain same.
understand?
No, that will remain
Okay.
same.
In most of the HAAR cascade
In every HAAR
filters.
cascade, it will remain same. In every, not most,
Okay.
every.
Okay. So the arguments related to the threshold and other things, that is 1.3 and 5, that you will explain as you give example, right?
Why I will explain. Already said no. The threshold value will be the value which will be given by us. So
Yeah, means what I meant is when we are doing some examples today, maybe
so threshold is
the
when we
coding part.
explained already, right? So coding part I have already explained you in last weekend that the threshold value is given. What I'll explain here. See,
Okay, huh.
this is number of neighbors. It's written here. What is 1.3? It's a threshold value. So if my this particular value is greater than equals to threshold, then it will be classified as the object. Or if it is not greater than your threshold value, then it will be treated as not an object. So
Okay, okay. So in case of a image with multiple faces, so we have to use it same way, but we have to modify the threshold in a different way. Correct?
if it required,
Uh, if it required. Okay. So that's what I just meant, because one image you have taken and you have shown the example. So if we have to detect multiple faces like in video and
doesn't
different,
matter with the multiple faces. It also depends upon video to video, or if it depends upon the light condition. If I'll be in the dark condition, 1.3 will not work, so I'll change it. This is value which has
okay,
to be changed by you. So that's why the logical
okay,
understanding is important. This is
okay,
thing. These are the things that you have to set up.
okay.
Only these
So
two.
we need to vary this to adjust so that we are able to detect all the objects.
Just only these two value, and it's been already given here. What are those? Now remember that where is my eye? This was
So just
about the
one,
face.
yeah, okay. The more the number of neighbors which will support in identification, the more better would be the feature extraction.
Not obvious. Not always.
Okay.
These are hyperparameters tuning. So how we can say about that? Are you done with your questions? So I can
Yes.
explain the next part.
Sir, how we can create these XML files for the faces?
There's no need to do this part. We will discuss the face detection and all in a much more better way through our other algorithms today. This is just a basic beginning. If you wanted to create HAAR cascade better than that, why not let's build a model?
But sir, if we want to create our own model for the face
That's what I'm
classification,
saying.
or
If I wanted to create our own model, we will better do it in a different way. Why we will do this basic thing? This is a very basic thing which is not even perfect. So we will go for the perfection, isn't it?
nowadays YOLO can be used for multiple face detection. So can we study this topic right here or not?
YOLO will be discussed later in our session. It is part of the topic. In the previous example, we have just used to detect the video. Through the video, we were detecting the face. In order to detect face, just now I explained you that we have got face cascade detect multiscale. Okay, before that, we first used cascade classifier, that is using your pre-trained XML file about the face, frontal face, and also we have got the eye. Once we have got it, we have got saved them in face underscore cascade and eye underscore cascade. Now face underscore cascade detect multiscale. This will be returning me our main thing, that is our faces coordinates. The face coordinates will be provided by, again, the same model part that we have learned, that we will take all the pixels under the white, sum them, and we will subtract all the pixels under the black region, and it will return me some value. Let's say that value comes out to be 0.5 or 0.6. This will depend upon images to images. This will depend upon images to images. So according to that, you have to choose your threshold value, and that is the threshold value that we have provided here as 1.3. It could be 1.3, it could be 1.5, it could be 2.1, any value you have to provide. This is just on the basis of your trial and error. We cannot fix or know this particular value. Now, this nearest neighbors thing, you can choose this an optimum number. Okay, not go for the do not go for a very large value, otherwise sometimes it can result into always resulting itself into not detecting the faces. So in this case, we have taken an odd number, which is 5. Try to take it as an odd number only, 5, 7, like that type of nearest neighbors, because we are doing binary class classification. Correct? What is binary class classification? Face is a positive image or positive detection, and not a face is a negative detection or negative image. These positive and negative images are stored here in frontal face. Similarly, in the eye, it contains all it contains the positive images of eye, and it also contains the negative images, which will be any other object but not the eye one. So our algorithm knows what is the characteristic or what is the value the eye can provide us. Only the selected eye can provide us, and what is the value that it won't able to provide. Now remember that I'm using here HAAR cascade underscore I, and if you are wearing specs, then it will not able to detect it. So kindly remove the specs, then only it will able to detect your eye clearly. In order to draw the rectangle around it, we are using here the frame, which is my original image. And as I said, that faces will return me 4 things in sequence: x, y, w, h. That is x axis and y axis coordinate and width and height of the face. So it will draw the rectangle around it. Now, where is the eye lies? Eye lies under the face. So to detect the eye, we have to first get the face ROI. The one importance of this particular thing is also to detect the faces. Suppose I wanted to build my own model, and for that I wanted to detect the faces. I can use this algorithm. Let's start with face detection, ROI. Let's get here ROI underscore gray will be given by gray, and it will take here 4 value: y colon y plus h and x colon x plus w. Next, ROI underscore color will take here frame, which is my original image, and we'll again do the same: y colon y plus h and x colon x plus w. So this will return me the ROI of face in gray color and ROI in colored image. Once we got the entire face, let's get here my eyes. Let's detect the eyes here. So in order to get the eye, I need to repeat it here. The same thing, but under the region of faces. Replace the faces by eyes to get the coordinates of the eyes here. Face cascade will be replaced by eye underscore cascade. In this, we don't have to provide the gray, but we have to provide the ROI underscore gray. And then you need to choose your threshold and number of neighbors, just like the way we did it here. Now, once it is done, let's run the for loop and draw the rectangle around the eyes. Let's get here my EX, EY, EW, EH in eyes, and let's draw the rectangle.
Please copy the code.
On eyes, cv2.rectangle, and here we will write here ROI underscore rectangle. Also, let's do here EX, EY, EX, EW, EY, EH, and let's take the colors. Maybe I will take here 255, 255, 0, and the width of the rectangle is 2. Something it says error here. EX, EY, EW, EH in eyes, and we need to write here, sorry, it has to be ROI underscore. So under the color image, we will provide here we will draw the rectangle around it, and rest all remains same. This is how your eye and face can be detected. Once again, I'll tell you, if you are wearing specs, please remove the specs, otherwise your eye will be not detected. This is the same error which I have already answered. Whenever you get an empty or anything, it means that your locations or path is not correct. Whenever you are getting these type of empty or whatever the this type of error is there, remember that it means your path is not correct. Try to remember it. This is the most common error you guys are making. Unread sample is called with an error status, global cap, anonymous. I can't say anything about that. I don't know what made you this error. Had you made anything? Maybe you are making some. This is not even the path error, seems to be. Okay, participants, are you able to detect your faces? Please remember that these are important things. Okay, do play with these values as well. If your face is not able to get detected properly, then try to minimize this, maybe say 1.1 or something like that. And this can be further reduced to minimum 3. So do try them. This is not a fixed number. Or if multiple boxes are getting created, there can be two possibility. Either your faces are not getting detected properly, or the other alternative is multiple box rectangles are getting created. If multiple rectangles are getting created, then in that case you need to increase these to 1.5 or 1.4, or you can also do changes in this. So if your face is not getting detected, then decrease this. If faces are getting detected with multiple rectangle boxes, then increase the value. These are the two things that you need to remember. Now I'm moving to the next part. Let's discuss here the.
Excuse me, sir. I am getting a rectangle on face, then on 2 rectangles on eyes, but 1 extra on the teeth. Why it is so?
That's what. If you are getting extra, increase this.
Increase this one. Multi-scale.
Depending upon the color, which color you are getting, the rectangle, is it detecting your teeth as an face or teeth as an eye?
Eye.
So increase in eye. Number of neighbors you can increase on eye. Increase more. Keep on getting until the rectangle moves away. It will. That's the only solution we have.
Sir, if I increase the number, means CV2 dot rectangle. इसमें करना ना. If I say 10, then it is
Not
like,
there, rectangle. Here.
Where?
DetectMultiScale is doing. The rectangle is not doing anything. Rectangle is just drawing the rectangle. This
Multi-scale.
detectMultiScale is doing that. Now let's move away here to our next example quickly. Let's start with the next part. In the next example, we need to discuss about the k-means clustering. Sorry, KNN. We will now create an algorithm that will able to detect uh, the person's face. Okay, this will be used to detect your faces here. You can call it as face recognition example. And in order to do that face recognition example, we need to basically uh, do two part. One will be the sample collection part, and the other will be your recognition of the algorithm, recognition of the face, in fact. So it's a two-step process. First step is about detect the faces, and the second step is about using that face to train our model, and then use it to particularly recognize if the face is found or not. The code will be a little complicated this time as we are doing the tough work this time. Before we start with this next project, we need to understand this that to detect the faces, this is the same example is needed. We just don't need the eye part, just need the faces. We applied here the face cascade and we captured the video. In this case, our main method is to continue to work on this to detect our faces. Okay. We have discussed about how to increase the resolution as well, like the frame resolution. If your resolution of the the video is small, you can increase the video frame resolution by making changes in the cv2.resize, and we can store them back. Now, in order to do that, before this, we can write here a condition if your return is true. If your return is true, then only we can increase the video frame resolution. And I'm going to increase it to a little larger, let's say 1280 cross 960. So basically, the smaller picture will now be enlarged to a larger resolution. This was discussed, I think, earlier as well. So not a new concept. We will be taking up my gray image. Let's name it as gray frame. This is my original colored frame. We have converted the color frame into a gray frame now. Now suppose if somehow we need to make a better code. So this is for return true. What is my meaning of return true? It means that if your video is detected, if let's say the video is not getting detected, then in that case it will continue to run the code. It will not break or it will not stop. So there are two options of return, which can return you true or it can return you false. If it returns you true, then it will resize the video and then it will show it. If it returns false, then it will mean that it will just simply continue to do it. Let's try to get our faces just like the way I explained you. Here I'll get it with 1.3 with 5. Again, remember that this will be changed according to the. Okay. After doing it, we generally what we do is we try to detect the face using this, isn't it? Now this time we will not draw the rectangle around the faces, but we have to capture the faces. We have to capture these faces and we need to save it for our uh, prediction model. Now in order to do that, I need to ask few details. Okay, so as of now my code looks very simple, that okay, detect the face, that's it. Once the faces are detected, then we need to save those faces as a numpy array file. So let's add some new additional code. This is your old code that we have used to detect the faces. So how do we start? We start by first adding a skip button to 0, which will be just a counter type of thing, and then to save the data as an array, as a list, I will write here as I'll create face data as a list value, and I need to create a folder location all images samples. In order to do that, I will write here dataset underscore path equals to, just create any path here, OpenCV, and in that I will use here something called as face recognition KNN. Under that I have got face underscore dataset where I will save everything. This is my path. Please do not copy my path. You can have your own path, but yes, try to have a separate folder where you will save all the files. Okay, do not save it in some general locations where other files are also present. Just save it in a location, in a location where only your faces are stored. Now let's move ahead. Here we got here my face data set. Moving to the next, let's start with enter the name of person. We take here file underscore name, which is given by, enter the name of person, which will change. And remember that this name of the person is a very important thing. We will try to take the name as my file name as well. That's why it is written as file name. So the name will be the person name that you wanted to show while the algorithm will perform the detection or prediction. In that case, your file name will play an important role. So few changes we have made. Let's move to the next part now. So we got it here as enter the name of the person, etc. Details are there. I hope you have tried and the code is working. Now we need to perform here few methods to basically know that if your faces are getting detected properly or not. So first of all, we need to confirm that if your face is got selected or not. So for that, it's very easy. We will simply take the length of the faces as 0 or not. If it is 0, then we will continue. If it is not 0, that means face is detected. Okay. As we know that the faces will store your XY WH value. So if the length of the faces is 0, it means face not detected. Faces equals to sorted function. I wanted to arrange them in sorted order. Faces, which is my data, P will be equals to a lambda function, x colon x of 2 multiplied x of 3, and we wanted to arrange this in a, it is arranged in a descending order. What exactly is this? I'll tell you in a minute. Okay, so remember that faces are gonna be my main data, right? These faces that we are taking the data set or the faces part, we are trying to sort them in an descending order, and the parameter by which the faces will be sorted will depend upon the x of 2 and x of 3. What is x of 2? X of 2 is basically your image height, and x of y is the image width. So basically we are sorting in a order of your faces height and width. This is basically the value of image height from the dataset faces, and x of 3 value of the image width from the faces. Now let's add here skip plus equals to 1. As of now, we have sorted that our faces are reversed from the detected one according to the height and width. Now we need to go through the loop of phase in faces, and we'll get four things: x, y, w, h will be given by your one of the face individually. Let's add a small, let's additionally add an offset value, which is basically a small boundary of pixels. We can have here offset, which is equals to 5, face underscore offset, which will be equals to, take a frame, we got here my y minus offset colon y plus h plus offset x minus offset colon x plus w plus offset. What exactly is the offset doing? Very simple. Earlier we were detecting this, right? The exact face. Now we are just adding few more pixels to it, like 5 pixels additionally. So the boundary will be little larger. We are increasing the height and width by 5 more pixels. That's the offset value we have taken. Okay. So the frame size, we will now, from the frame we will add some offset value, and we will detect a little larger portion of the detected face, so that it will be good for us in making their algorithm predictions. Now at the same time we wanted to change the resolution of the face of having the same shape. This is very important. cv2.resize, this is the function to resize the available original face. The original face data is stored in face underscore offset, and this must be resized to 100 cross 100. Let's try with if it's skip percentage 10. Let's compare if it is 0 or not. Now what is this? We don't want to make a fast selection of the faces. We wanted to slow it down. So what we are doing here is that we are selecting every 11th face. Okay. Or you can say that we will, basically it is divisible by 10, right? So yeah, we will select every, this is done to slow the face detection. And in order to slow down, you can add delay as well, but delay will have its own consequences. In order to delay, better to, what we can do here is to detect the faces. What we can do here is that we can simply add a skip button, which will skip 9 images, and it will select the 10th image. Okay, makes sense? This is basically to skip the count of the images by 10, and it will detect the 11th face, like that, or when the count is divisible by 10. So yeah, every 10th images. Now we know that face data is basically where my data should be stored, so we will append it to my list, and that's why we have learned about the Python, so that these basic things you can recall. We will start with face selection, and this is done. Just to confirm if everything is working fine and we are selecting the faces, we should print the face data length, which will print me the number of faces that has been stored. 1, 2, 3, 4, 5, 6, like that it will print. cv2.im show. On the images, we wanted to display the number of face that has been detected, and the face selection part. Increase the k value, acting like a counter here. So originally my k was stored as 1, which is for first image. Basically, you can write it as a counter value. Now, after doing all this, draw here cv2.rectangle, frame, put here my x and y, x plus w, y plus h. Now let's draw the rectangle around it. Once it is done, let's display cv2.imShow. And we will wait for any button to get pressed. Okay, so how many faces you should detect? 200 to 300. So with this example, if you will try, it will start detecting your faces. Okay, and when you will press Q button or escape button, it will separate window will get opened where only the faces will be displayed. And on the right hand side over here, you will see the number getting printed. 0, 1, 2, 3, sorry, 1, 2, 3, 4, 5, 6, like that it will continue. Did you pass the name? When you will play the button, it will ask first enter the name. Let's say I'll write here my name. I'll press enter and it will start detecting your faces directly. It's working in mine. It is working in mine. It should work in yours as well. So the code is shared here in your specific window here, as you can observe. This is the second code, sample collection. It will open up two windows. I think the video is crashing. The detection is working, but I think we need to change it in this particular example. I need to change it. Rest all is fine. So this is the type of value you will be getting. Number appears means everything is fine. But yeah, there is one thing that we need to discuss, and that is about this K thing has to go, because K is at the top as well. This should be changed to key pressed. K is actually used here as well, right? So that's why we need to change it to key pressed. Wait key, and we need to compare here the key pressed. ORD. Let's keep it to only one button, that is pressing the small Q. That's a small change that we are making. Here I made the changes. The K has to go and it has to be replaced by key pressed. Otherwise, the code is working. So I tested it. It is working and it is detecting the faces, but it is not saving anywhere, of course. So we will discuss here the rest of the thing. The rest of the part we will discuss after the short break. Okay, now let's add the faces to my location. This is the path. As I told you that this is the path where I will save the data. Where is my data? Tell me. So my data is here. Face data.append, which is a list data, and we need to convert them into an array. Face underscore data will be equals to np dot array. Then we can take here face underscore data. After doing this, we'll start with face underscore data, which is equals to face underscore data dot reshape, and we need to reshape it with face underscore data dot shape 0. Okay, then we reshaped our image according to the shape of the face data. Let's print face data dot shape if you wanted to see that, and let's start saving it. np dot save dataset underscore path plus file name comma face data. Face data is the value. The file name will be the person's name, and it will be saved as an npy file because it is a numpy save. Now let's print to confirm that your images are getting stored somewhere. So images saved at dot format. Provide here dataset path plus file name dot npy file. Now we need to do the video release or capture release here and destroy all the window. So why the images were not getting saved? Because we have not done this line. Only one line was needed where we have got the path. File name will be the name that you are mentioning, and let's save them as your face data, and it will be stored in the location. Why npy? Why not directly? What is this face underscore data? Can you tell me from the explanation that I gave? What is face underscore data? It is an array. Array of what? When we are trying to save multiple faces at a time, how we can save it as .jpg? Is it possible to save multiple images? No. So what are we try to do? We will simply create a collection of face that we created here. So let's add, this is your collection of faces. If it is collection of faces, we need to save it as a file. What type of file we are creating? An array file. And in that we are having multiple faces of the same person. Now one thing you need to remember, participants, that please take different faces. So collect minimum 200 to 300 faces. 200 is enough, with different face gestures, face emotion. Okay, different face emotions and different gestures. Basically, you can provide some side angles of your face if it is getting detected. Smile, okay, normal face, sad face. Try to get different emotions as well, so that the algorithm can learn about your face in a much more better way. Please make sure that it is able to detect only the faces. If it is detecting something else, then do make the changes and try to collect the faces again. Please ensure that it only detects your faces, and at a time only one person should be there in the front of your web camera. Similarly, you can use it to detect multiple persons as well. Let me make some changes if it is needed. But that is not stopping your program to work. No, it is still it will able to save everything. That problem I will try to resolve. If it is not getting saved, please check your location. Once you stop, once you stop everything, it will automatically give you the output as that the image is saved. If everything is correct, like I just tried on mine, so you can see that the file is still created. I deleted it earlier, so it's created again. And see, I'm getting the output here. This type of output will be returned. But my question is why it is getting hanged. Key pressed, should break. Okay, what about the images that we applied on the images?
Sir, should we create a folder name as face dataset, or automatically it will create in the directory? Should we create a folder name as face dataset, or automatically it will create the folder and save that?
Folder will be not created automatically. That is what I said at the beginning. Folder has to be created by us. Select around 200 images. Once it is ready, we will go to the next part. So maybe you can try to save it later. Let's discuss our next part, which will be discussion on KNN. This is a fully working code, so please take care of your locations. That's where you're making the mistake, if the images are not getting saved in the end. Are you able to see the numbers first, Abhishek? If no, numbers will tell you that how much time it will take. That means you are not in the correct way of doing the coding. You might be having some mistake then. Take the code again and try to check. where you are making the mistake. Okay, so it is closing, guys. All right. The point is that you need to. There are two windows which are getting opened if you have checked. One is a bigger window and one is a smaller window. The smaller window only shows you your face selected, and the bigger windows shows you everything with a background. So check that smaller window, and then on that you need to press the Q or escape button multiple times. Q button will work in this case because we have written only ORDQ. It should give you the number 1, 2, 3, 4 like this. The counter will continue here. Like you can see 1, 2, similar to that. Once this number reaches to 200, you can take the smaller window, select it and press Q button multiple times. That's a mistake. Check where you are making the mistake.
Sir, can I see your folder, sir? Where it is saving?
Let me see a couple of your issues. Let's start with Abhishek, right? Where is he? Abhishek, and there are two Abhishek. Abhishek. Where is Abhishek N? Here. After pressing Abhi, why you are not pressing enter? After writing the name Abhi, you have to press enter. Pressed.
Hello. Yeah, I pressed it. After that, I've got two windows also. This is the window which, but after that, there's nothing.
What happens when you press this Q button?
After a while, after 20-30 seconds, I get this two windows.
Close the window.
I'm not able to do it. It's showing as face not responding. I pressed Q and this multiple times. I'll just check.
Then there is on the right hand side we have got 3 button. Go to that. On that same right side window there is a 3 button, right? 3 lines are there. 3 lines, not 1 line.
Yeah,
Click on that, restart the kernel. Where can you show me the location where you are trying to save?
Yeah.
Show me the path. Go back to your dataset path. Place it here.
I'll place it here.
Yeah. Remove this. Paste it here. Forward slashes. Forward slash in the end of the face dataset.
Oh,
1 second.
yeah.
Forward.
Maybe that is one which is creating a. Yeah.
1 second. We are not done yet. Go to your go to the snipper path where my codes are present.
Should I run it now? I've saved it.
Yeah, but you need to restart first your kernel, as it will be executing the previous code first. Execute it.
Yes, executed.
No, it's not done yet.
Yeah. Just a minute, I think so. Error.
Okay, now I understood like what is your error. So you can stop shading. Let me see somebody else now.
Yeah.
Yeah, I could get it, sir. It is saving.
If you will be also placed in the camera, your faces will be also saved in by the name of the other. We are generating the samples here. We are trying to learn how to generate the data. And yes, remember that all the faces are reshaped to 100 cross 100. So every images will be what? Each image will be of 100 cross 100 cross 3. Remember that. So first value will be your number of images. Please remember that. Okay, now let's try to discuss about the k nearest neighbor. K nearest neighbor. Data is, I'm hoping that your data are getting selected now. There's no problem in that. Just now we need to learn about how to deal with our k nearest neighbor things. In k nearest neighbor, we'll start with a certain points. Number 1, KNN is a supervised machine learning algorithm. If it is a supervised learning algorithm, so we'll have a known target. So basically we are solving for or creating a model for a non-target. Point number 2, it is non-parametric. Non-parametric means it does not uses probabilistic distribution to find the prediction. Usually the algorithms are divided into two parts. There are algorithms which basically predicts in probability form, that okay, this is the probability for label 0, this is the probability for label 1, this is the probability for label 2, and so on. Numbers will be given in a probabilistic form. But this is those algorithm which does not it does not perform something like that. So that is what the non-parametric means. It does not gives output as probabilistic distribution. Also, it does not make any assumption about data distribution, pattern. Value number 3. This is a lazy algorithm. It takes a lot of time to come to the conclusion. It is one of the laziest and one of the slowest algorithm. Even if it is one of the slowest algorithm to get implemented, KNN algorithm used for both regression as well as classification. Step number 5. KNN uses feature similarity to predict grouping. In our case, we will be, of course, targeting to use the KNN as for the classification part. Find the nearest neighbors. Find the nearest neighbors for new classification or for new data set for which we have not performed the classification yet. Let's pick here my two samples. This is my first sample number 1. That's my sample number 2. And this is my new sample. Now, we already know that these two samples are already classified as class 0 and class 1. These are already labeled as class 0 and class 1. It has x1, y1, x2, y2. Let's take the nearest distances like that with my new sample, which goes with my x3, y3. The concept is very simple. These are my labeled data, which are already labeled as a class 0 and class 1. Imagine that this is for person 1 and this is for person number 2. So this new feature has been extracted, which is giving me x3, y3 as a value. So it will try to compute which one is nearest. In order to compute the nearest distance, we'll have the distances value d1 and d2. So let's compute the nearest neighbor. Now we uses here Euclidean distance formula, which is given by under root of x1 minus x3. We take the square of it plus y1 minus y3 and we take the square. This is how my d1 will be calculated. In order to calculate d2, we will see it as x2 minus x3 square plus y2 minus y3 square. Whichever is nearest, whichever will be the nearest distance to the available label, this will be classified as to that particular label. That means whichever will be the smallest value of d, that will be the predicted label. So nearest to the new sample, if label is a 0 or label is 1. The word is nearest neighbor, k nearest neighbor. What is k indicates? K indicates here the number of nearest neighbors value that you will see. That means this k value will be the deciding factor. You can have k as 2, 3, 4 like that. So let's assume the scenarios, and in different scenario what would be the importance of k. For example, I go with k equals to 2. So here your k decides your number of nearest neighbors. Here k is your number of nearest neighbors. Now let's start with okay, we have got one label and we have got the second label. Now imagine that this is how my distributions were. Now imagine that we had got actual distributions which appears like this. There will be multiple images which are getting selected, and these are the multiple features which has been taken. Similarly, we'll have for the red as well. Now once we have taken all this value, let's try to have the new sample as well, and this is where my new sample will lie. If that's my new data, let's try to take the distances from here. Let's try to get the distances d1 and d2 for the label 0 and label 1. This is my class 1 and this is my class 0. And for this new data, my nearest distance to it will be equal. Let's assume that. What if both are equidistances from new sample data? So for both the classes, distances are same or equidistances here. So hence d1 will be equals to d2. So in this scenario, any one can be predicted. Obviously, there will be prediction, but in that case, we will not have the conclusive evidence, and the algorithm could predict it as a 0 or 1. Might be resulted into a wrong value. So what is the solution? The solution is that we have to go for a larger value of k. Specifically, if you are dealing with a binary class classification, you should go for an odd number of k. And if you are going for, let's say, k equals to 3, so your k value should be always in sum. If your number of classes are odd, then choose an even number of k. If your number of classes are even, then choose an odd number, so that at least one of the label will be there, one of the sample will be there, which will change the vote, and you will not have a scenario of equal voting. Let's say if I'll go for k equals to 3, so in this case your performance of the value will increase. So the answer is very simple here, that with change in k value, the value of the k, this will improve performance of KNN model. We can have k equals to 3. It will choose 3 nearest neighbor. We go here with my x1 and x2. Okay, here are my distribution of the data. Let's pick my new sample data here. This is my new sample. Now in this case, if I take my k equals to 3, so you will easily see that this will be the nearest neighbor, this will be the nearest neighbor, and this will be the nearest neighbor. In order to find out the nearest neighbor, that will be the first criteria. You will choose k equals to some nearest neighbor. Once we have taken the nearest number of neighbors, then what we will do, okay, this has been number, but how we will decide that which are my nearest neighbors? So for that, it will basically calculate the distances between all the value, which makes it one of the slowest algorithm. Remember, I have written it as a point. So basically it will calculate for all the sample first, the distances from new sample to all the data points. Then only it will come to the conclusion which are nearest data points, right? So it will try to calculate it from all and then come to the conclusion that which are nearest neighbors. So we need to calculate here the distance between new samples, and all the samples are labeled as class 0 or class 1. And then it will choose which are the nearest neighbor, and according to that it will work. Okay, and the deciding factor will be through the voting. Makes final prediction using majority vote. So there could be possibility that a sample which is predicted for k equals to 3 as 1, in that case, if you will change the k value to 9, the predicted output might change. So you have to go for a higher value of k, like k equals to 10, 15, like this type of higher number, so that the algorithm can make a better prediction.